How much of an initial investment would you need for it to be worth at least $3,000? This at least right here, you want to underline that. That at least $3,000 is going to be very important. The word at least means we have an inequality, because these are inequalities. So we're compounded yearly. So we're compounding yearly, so this is not compounding continuously. If we use continuously, why don't you use the PERT one? We are compounding yearly, so we're going to use this formula in the bottom corner. Our rate is 5% over 5 years. We're going to create an inequality. So we want an inequality, which means we're going to have our final answer will not have an equal sign. It will have a greater than, less than, or something like that. We're not going to solve it. In the end, we want an inequality that will give us our initial investment. So to start these problems, we want to list out all the pieces. Meaning, I want to find A, P, R, and T. Once I know all those pieces, I'm going to list them out. I'm going to plug them all in to make an inequality. So looking at the problem, do we know our A, our final amount? Yes, we do. Isn't it at least $3,000? So our A value, our final amount, is at least $3,000. So let's write that down. Next, let's look at the next piece. Next piece is P here. So P, do we have a principal, an initial value? No, isn't that what they're asking for? So our initial investment's missing. So what we're looking for, our P, is our question. That's what we're asking for. So P is going to stay P. We don't know its value. Next, R. What is my rate? Well, isn't that 5% right there? Now, is this growing or shrinking by 5%? It doesn't say, but can we imply if it's money and you're investing, it's probably going up? I forgot to say that it's increasing. Let's imply it's increasing. If I forgot, let's say it is increasing, assuming. So I kind of made a mistake there in the problem. So we're increasing by 5%, so isn't that a positive 5%? What is that as a decimal? Let's write that as positive 0.05, because we're going to need the decimal in a little bit. So we're growing by 5%, which is 0.05. Next, time. Do we know our time? Yeah, 4 years, because we're doing years compounding. So my time frame is 4 years, so my time is 4. Now what we're going to do is we're going to take and plug all those into this right here. And then we're going to make it an inequality last. So as an equation, it's going to be 3,000 equals P, 1, get that 1 right there, plus, because we're growing, 0.05 to the T, which is 4. That right there is my equation, but we're going to need to do an inequality because that's what it's asking for. I took my pieces, I plugged them where they belong. Last step is I need to change this to a greater than or less than or something to get at least. This at least here is a little tricky. All right? So in order to do that, I personally want to do this. I'm going to change it to put P first. I'm also going to combine 1 and 5 cents, or 0.05, and get $1.05. So I'm going to put that first, and I'm going to put this over here. For me, this makes more sense when I'm saying this is at least 3,000. To me, it makes more sense to write it this way than to be reading backwards. I don't want to read backwards in my brain. Got it? Because it's saying at least that. So we have to start now. What kind of inequality makes an at least? To be at least, what it's saying is to be at least 3,000. Are we looking at something below 3,000 or above 3,000? If it's at least 3,000, isn't 3,000 the lowest it could be? Aren't we looking for something above 3,000? So to be above 3,000, won't that be that sign? If we're saying at least 3,000, isn't 3,000 the lowest and we're looking for something above it? So that right there is our inequality, which you could solve, even though it says not to. We're not going to solve it. That would be, if you solved this, you'd find out how much would you have to start with to make sense of this problem. be very careful. The inequality will get you. You got to be careful with that at least. And watch, if it says inequality, it's an or equal to, less than or greater than. If it says an equation, then you just have an equal sign. There are 2,000 fish in a pond, and their population is decreasing. Let's understand that. Let's underline decreasing. That's going to be important. What's also really important is this next sentence, at a continuous rate. Continuous rate is why we're using this formula in the corner. Whenever you see the word continuous, we're talking about a natural growth or decay, and in this situation, it's a decay. So we have this E formula. So keyword is continuous. All right, we're going to do an inequality, so we're going to have a greater than less than at some point. And our question is, how long will it take for there to be at most, again, that at most idea, at most 10 fish. So that's going to be an inequality. So let's take all this, let's figure out what A, P, R, and T are. Let's put it together, making an inequality. So A, do we know how many fish there are in the pond to start with? Yeah, it says 2,000. How do we know it's 2,000? There are ways to figure out and estimate the number of fish in a pond. You can do that. I'm not going to do that here. P, do we know our final amount of fish we're looking for? Sorry, I messed up, huh? Yeah, let's go back and fix that. What did I mess up with? Well, isn't this right here your final amount? And what is the final amount? Isn't the final amount going to be at most 10? What's our P, our initial amount? 2,000. That's important not to mix those up. If you look at the problem when you're done, it should make sense. So watch out for that kind of thing. The reason I put the word at most is because that's going to be important for inequality. So I thought I'd write that. Next. All right. We have R. We have R sitting right there. R is a decreasing of 20%. So can I put negative 20%? And if we write that as a decimal, can I write that as negative 0.2? All right, and do we know the time frame? Yes. Wait, no, that's what we want to know, huh? Isn't that what it's asking for? How long? So we don't know why these fish are disappearing. Maybe people are fishing and taking them out. Maybe they're dying. I don't know. So let's plug these all in. So our A is 10. Our P is 2,000. E, the rate is negative 0.2. And we don't know T. T is what we're looking for. So there is an equation where I plugged into this right here, all these pieces. So let's now change this to an inequality to have at most 10. When I do an inequality, I'm going to first write the 2,000 e to the negative 0.2t first, and then put 10 there. I think it's easier to read when you put it in this format. Now, when it says at most 10, is that going to be greater than 10, less than 10? Well, if it says at most 10, isn't 10 going to be the... Wait, if I say at most 10, isn't 10 the highest? So don't I want something below that? You have to pause and think sometimes, and hopefully you can see I'm looking for something below 10. Because if you think about it, didn't I start above 10? So aren't I looking for something below 10? Otherwise, it wouldn't make a lot of sense. So what I have there is my inequality for this scenario. Now, could I solve this? Yeah. If I did solve this, I'd have to use logarithms. And I could find out how long it would take for this 2,000 fish to drop down to 10 if they were actually decaying at 20% continuously.